Jupiter is not just a giant among the planets of our solar system. It hides many secrets that until recently remained a mystery to humanity. Our understanding of Jupiter changed with the launch of the Juno mission, which lifted the veil of its hazy cloud cover and revealed the extraordinarily complex and mysterious processes occurring on its surface and within its depths. This world, full of incredible phenomena, continues to amaze and inspire scientists and researchers. Jupiter is not only about beautiful photographs and unique atmospheric phenomena. It is a planet that has a profound influence on the entire solar system's order. What secrets does this giant conceal? How can it be both a protector and a destroyer for Earth? If you're curious to learn more, give a like and subscribe. The Juno mission was developed by NASA in the early 2000s with the goal of studying Jupiter in detail, including its gravitational and magnetic fields, as well as the structure of its atmosphere. One of the main objectives of the mission was to confirm the hypothesis that the gas giant has a solid core. The spacecraft was launched in 2011, and after 5 years, it reached its destination. However, the mission faced significant technical challenges during its implementation. Initially, it was planned that Juno would orbit Jupiter with a period of 14 days. However, due to the failure of the main engine, the spacecraft ended up on a more elongated intermediate orbit with a 53-day period. Despite this setback, NASA quickly adjusted the mission plan, adapting it to the new conditions. As a result, the unexpected orbit even provided scientists with an additional advantage. It allowed for more detailed study of Jupiter's largest moons, which would have been difficult in the original plan. Juno became the first spacecraft to operate on solar panels in such a distant part of the solar system. All previous missions to Jupiter used radioisotope generators. The spacecraft's solar panels cover an area of more than 50 square meters, which is necessary because the intensity of sunlight at Jupiter is 27 times weaker than on Earth. Another critically important design feature was the protection against the planet's powerful radiation belts. For this, the sensitive electronics were placed in a 1 centimeter thick titanium protective module capable of withstanding extreme conditions. The spacecraft is equipped with 9 scientific instruments, including an ultraviolet spectrometer, a magnetometer, and a charged particle detector. However, the most famous instrument became the Juno camera, which was initially not even part of the mission's planned instruments. NASA had not planned to equip the spacecraft with optical tools, considering them unnecessary for scientific tasks. However, thanks to the persistence of amateur astronomers and the scientific community, it was decided to include the camera in the project. A special platform was created for it, where enthusiasts could vote on which areas of Jupiter's atmosphere should be photographed. Thanks to JunoCam, the world saw unique images of polar vortices, the cloud cover structure, and the planet's moons, including Ganymede, Europa, and Io. What new hypotheses about Jupiter's internal structure have emerged thanks to data from the Juno mission? Why is Jupiter's magnetic field so different from the fields of other planets? And what unexpected consequences might arise from its unique structure? Magnetic fields are present in many celestial bodies, including Earth. They arise due to the movement of liquid conductive layers in their interiors and play a key role in their interaction with streams of charged particles. The Earth's magnetic field is structured similarly to that of a typical bar magnet, with clearly defined north and south poles. When the Juno probe reached Jupiter's orbit in July 2016, it allowed scientists to create a detailed map of its magnetic field. It turned out that Jupiter's magnetic field is much more complex than Earth's. Unlike the classical dipole field of Earth, Jupiter's magnetic field has an asymmetrical, curved shape with significant distortions at its ends. One of the most unusual features is the location of one of its poles near the equator. According to Kimberly Moore from Harvard University, the lead author of the study, These findings seriously complicate our understanding of Jupiter's internal structure. Current theories explain fields similar to Earth's or Saturn's, as well as chaotic structures like those of Uranus and Neptune. However, Jupiter's magnetic field does not fit into these models and remains a mystery. Among the hypotheses attempting to explain its complexity, two stand out. One suggests that deep within the planet, turbulent layers of liquid metallic hydrogen interact with dissolved rocks and ices, causing significant disturbances in the field's structure. Another hypothesis points to the influence of large-scale atmospheric processes, which may affect the movement of material at significant depths, despite the planet's lack of a solid surface. What lies beneath Jupiter's thick clouds, and is it possible that processes exist deep within the planet that we are not yet even aware of? The atmosphere of Jupiter is renowned for its powerful vortices, the most famous of which is the Great Red Spot. This gigantic storm, rotating counterclockwise, has been raging for over 100 years and is so enormous that it could swallow Earth. However, until recently, scientists were unaware of how deep it extends. Using data gathered by NASA's Juno spacecraft, researchers conducted microwave and gravitational measurements to peer beneath Jupiter's cloud cover. It turned out that the storms on this planet reach much deeper than previously thought. The Great Red Spot is a high-pressure zone that creates a powerful anticyclonic vortex, the largest in the solar system. Its winds reach speeds of over 643 kilometers per hour, several times greater than the strength of hurricanes on Earth. However, this storm is by no means the only one. Nearly the entire atmosphere of Jupiter is covered by similar tempests. Unlike Earth's hurricanes, these storms can exist for incredibly long periods because the planet has no solid surface, and its weather is fueled by internal heat. It was previously believed that storms formed only at the depth where sunlight penetrates and where clouds can form from condensing water. However, new research has painted a different picture. Analyzing the data collected by Juno showed that the Great Red Spot extends to depths ranging from 300 to 500 kilometers. If such a vortex were to form on Earth, it would reach the orbit of the International Space Station. Is Jupiter a shield protecting Earth from cosmic threats, or does it, on the contrary, attract dangerous celestial bodies, creating an additional threat for us? What would happen if Jupiter didn't exist? Would Earth become more vulnerable, or on the other hand, safer? Jupiter has long been considered Earth's main shield, protecting it from collisions with asteroids and comets. It was believed that its immense mass and powerful gravitational field attract potentially hazardous objects, thus preventing them from striking our planet. However, recent studies have shown that its influence is far from straightforward.
Jupiter's gravity can indeed alter the trajectories of asteroids and comets, but this doesn't always lead to their destruction. In some cases, it acts like a slingshot, accelerating objects and directing them into the inner solar system, including toward Earth. Therefore, Jupiter's role cannot be simply classified as protective or threatening. It plays a dual role.
On one hand, its gravity stabilizes the asteroid belt between Mars and Jupiter, preventing chaotic movement of its objects. Moreover, a significant number of space bodies do indeed fall onto Jupiter, as seen in 1994 when fragments of the Shoemaker-Levy 9 comet collided with its atmosphere, leaving massive scars larger than Earth. Statistics confirm this trend. Collisions with Jupiter occur 2,000 times more often than with Earth. On the other hand, Jupiter is capable of ejecting objects toward the inner planets. Calculations show that without its presence, the orbits of asteroids and comets would be less disturbed, potentially leading to fewer collisions with Earth. Nevertheless, in some situations, its gravity plays a positive role, casting comets from the Oort cloud beyond the solar system, preventing them from reaching Earth. Jupiter, with its unique characteristics, continues to be the subject of deep research and attracts the attention of scientists and astronomers worldwide. The Juno mission has provided an unprecedented amount of information about the planet, opening new horizons in the study not only of Jupiter, but also of broader processes occurring in our solar system. Scientific discoveries demonstrate how multifaceted and unusual this planet is. With each new discovery, Jupiter becomes even more mysterious and captivating. Nevertheless, many questions remain unanswered, and every new study brings us closer to unraveling these mysteries. If you want to keep up with the latest news about Jupiter and other space discoveries, subscribe to the channel and stay updated on the freshest research.